Hello everyone. In this video, let us discuss about the charge distribution on metal objects. So, coming to the charge distribution on the metal objects, generally we already know a simple rule that when charge is given, whenever we provide charges given to a metal body, if we provide a charge to a metal body, what happens is due to mutual repulsion, the charge will get automatically distributed onto the surface, meaning so it spreads automatically on the outer surface of the body, onto the outer surface of the body. This is clearly known to us from the previous concepts. Now, what happens when I'll take two conducting metal spheres? To understand this charging or charge distribution on metal bodies, I'll consider two metal spheres, conducting metal spheres. So, one of radius r1, one metallic sphere, conducting metallic sphere of radius r1, and the other is of radius r2, and onto this we have initially, if they were at a mutually large separation, and we don't have to, we should be considering that we have a charge initially on these two charged bodies. For example, if I take this charged conductor is of radius r1 and this is of radius r2, and we have a charge distributed on the first sphere as well as the second sphere, and that charge on the first sphere I consider it to be a positive charge, or okay, well, let us assume that the charge on the if you have them at a large separation, let us assume that the charge on this metallic sphere of radius 1 is q1 and the charge on the metallic sphere 2 I take it as q2. So now what happens? They are at a mutually a large separation. Now what happens if these two spheres are connected by a metal wire? If I consider a metal wire connecting these two spheres like this, if I have them connected with a metal wire, what happens is charge flows from the body with a higher potential to the body with a lower potential. Means charge flows from a body at higher potential to the one at lower potential. So once we connect these two charged bodies, and what happens here, this charge will flow from a body at higher potential to a body at lower potential. Till when will this take place? Till what point will this be taking place? Until this transfer of charge will take place till the potentials of each sphere becomes the same, until their potentials become same. That is, potential of R1 should be equal to the potential of the sphere R2 of radius R2. So that means by this we can also say that the potential difference will be equal to 0. The potential difference will be equal to the charge will transfer till the potential difference across these two conductors when they are connected becomes 0. Till then is when the charge get transferred from one body to the other, from the one at higher potential to the other at lower potential. So now after we have a conclusion there that the charge transfer ended, and now after this charge got transferred completely and their potentials are same, let us assume, let us take q1 f and q2 f are the charges on the spheres after they attain same potential. After they attain the same potential. Now, as we clearly know that potential of R1 should be equal to the potential of R2, then by then the charge transfer will get over, and we will have K into Q1F by R1, the potential on sphere of radius R1, and the potential on R2 is Q2F by R2. So, and if I take here a consideration, if I assume that sigma 1 is the charge density, sigma 1 is the charge density on sphere of radius R1, and sigma 2 is the charge density on the sphere of radius R2. And then what we can have is Q1 final charge will be equal to sigma 1 into 4 pi R1 square, the area. In Q2F, the final charge on the second sphere will be equal to sigma 2 into 4 pi R2 square. So using this relation, if we have it here now substituted, K will get cancelled, and I'll have Q1F as sigma 1 into 4 pi R1 square divided by R1 is equal to sigma 2 multiplied 4 pi R2 square divided by R2. Now if we cancel out the square and this R2 here in the denominator, what we will, and also the 4 pi on either sides, what we remain is with sigma 1 into R1 is equal to sigma 2 multiplied R2, sigma 2 R2. Now we can write this relation as sigma 1 divided by sigma 2 is equal to R2 divided by R1. This is the relation in terms of surface charge density for the two metallic spheres that are initially separated by a large distance, on which there was an initial charge of Q1 and Q2, and once they are connected by a wire, conducting wire, their charges becomes Q1F and Q2F, and this charge transfer will take place across these two conductors till their potential difference becomes 0, or till they attain the same potentials. And using that condition, we have arrived at a relation where equating the potentials of these two surfaces, and we have arrived at a relation for charge densities on these two surfaces. Thank you.